Hello everyone, welcome to this demo. My name is Tulio. I have a bachelor degree in electrical engineering, an MBA in project management, and a master degree in energy management. In addition to my academic background, I have more than 5 years of working experience with electrical power equipment, quality assurance, and also project management. And today I would like to introduce a solution that was developed using Matlab, which is an app for rebalancing capacitor banks after the failure of capacitive units. So the main purpose of this demo today is to introduce a methodology that was developed using Matlab App for rebalancing a capacitor bank in the double star connection neutral not connected after the failure of one, two, or many capacitive units. So in the electric system, we have different typologies of capacitor banks. So in this case, we are presenting a solution for the double star connection neutral not connected, which we can see in this picture highlighted here. But it's important to emphasize that the solution can be developed for any typology of capacitor banks, as we can see here in this picture. So, but what is the problem of capacitor banks over the time? So in this picture, we have the capacitance map for a respective capacitor bank with the distribution of all the capacitive units, which includes some important informations for each capacitive unit, which is the address of the capacitive unit and the capacitance value. And as I mentioned before, over the time, so these capacitive units can suffer with some dielectric failures. And due to these failures, we need to do the replacement. But the big question is how to handle the replacement of capacitive units after it's failed. So worldwide, the best practice mentioned that an effective rebalancing of capacitor banks after the failure of one or more capacitive units is with the spare unit that gives us the unbalanced current below 10% of the predetermined alarm level. So here in this picture, we have the configuration of a double star neutral not connected capacitor bank. Here we have the protection relay, and in this relay we have two sets. The first one is the alarm set, which is 1.5 milliampere, and the second one is the trip, which is the 2.3 milliampere. So in this case, to say that the capacitor bank after the failure of a respective capacitive unit is rebalanced, we need to have an unbalanced current below 1.5 milliampere, 10% less than 1.5 milliampere. And the question now is, sometimes it's easy to do this task with one or even two capacitive units, but what about the situation when we have to do the replacement of 3, 4, 5 or more capacitive units? So that's why the solution using Matlab app was deployed. So here we can see the user interface. I'm going to open the user interface later to make a quick demonstration of the app. But basically, the solution provides us to simulate up to 5 spare units at the same time. And among these 5 spare units, the app is able to identify the best spare unit to enter into operation. It also provides the theoretical unbalanced current between and after the, before and after the replacement. And also after the replacement, the capacitance map is automatically updated. And when we are inputting some informations for the simulation, such as the address of the capacitive unit, and the capacitance value, the app has some features that allows us to check, for example, if we have any mistakes related, for example, with spelling. And let's now do a quick demonstration. Let's say that after the failure of this highlighted capacitive unit, we need to do the replacement. The unit address is L1, 1R1C03. So the capacitance value is 28.11 microfarads. So in this case, we have 4 spare units available for the replacement, and now we need to decide which one is the best to enter into operation. So in this case, the first step that we need to check here in the user interface, we need to check the spelling of the address of the unit. So here we have L1, 1R1C03. So that's the address that we need to do the replacement. We click on the button check address. If the light turns green, it means everything is okay. But if not, there is some mistake that we need to fix before we move forward. So the second step, we need to enter the values of the spare units available. The first one is 27.997, the second one 28.76, the third one 28.45, and the fourth one 27.45. So in this case, we are not using the 50 spare unit for simulation. So we click on the button check values. In this case, we have 3 green lights, 1 red light, and 1 yellow light. So the yellow light means that we are not using the spare unit available, but the red light means that these values is too low for the simulation. Maybe there is a spelling problem here that we need to fix. Let's say we are gonna put now 28.45, and let's run again the check value. If everything turns green, we can move forward. So in this case, now we can move forward. We need to click now on the button yes. The button yes enables the button start. We click on the button start, and below here, we're gonna see the new value for the unbalanced scoring, which is 72.71 milliampere. Using the spare unit with the value 27.97. So in this case, the best spare unit to enter into operation is the first one with the value of 27.97 microfarads. So if we decide to move forward with the replacement, we need to click on the button below here, yes. So this button enables the button update spreadsheet. So if we click here, the next simulation that we run for this respective capacitor bank will also include the new value of 27.97, as we can see here for the address L1 1R1C03. But in this case, we are just doing a quick simulation just to see how the app works. It's just a demo. So we can click on the button reset. So all the informations are erased. And now we can go back to the presentation. And I hope this demo was useful. If you have any question, please feel free to contact me through my email here or in my LinkedIn. I'll be more than happy to have you in my connections. So here is some references that I used to develop this solution, the app. And other than that, thank you so much for watching it. I'll see you again soon. Thank you.